Hello students, in this video I am going to discuss the hexadecimal to binary encoder. But before that I want you all to understand what is the encoder. So students, encoder is a combinational circuit, and what is the job of the encoder? Its job is to convert one base type of number. Yes, one base type of number to its binary representation. That means that one base type of number which is going to be represented through binary is going to be octal, hexadecimal or decimal. So three types of encoders: decimal to binary encoder, octal to binary encoder, and hexadecimal to binary encoder. Now we get back to the main topic, that is the hexadecimal to binary encoder. So hexadecimal number will be the input, and binary representation or its binary representation is going to be the output. 16 numbers are there in the hexadecimal number system, that is 0 to 9 are the numbers, and after that A, B, C, D, E, F are the alphabets to represent the numbers like 10, 11, 12, 13, 14 and 15. Alright. Now encoder that converts hexadecimal or base 16 number to its binary or base 2 representation is called hexadecimal to binary encoder. It is also known as 4-bit encoder, okay, and also called 16 to 4 encoder. Let me explain it to you. Here is a block diagram you can see of the 16 to 4 encoder, and here you can see the inputs, 16 number, that will be the hexadecimal numbers, and 4 are there for the output, that is going to be the binary representation of the hexadecimal number. Okay, so 16 inputs and 4 outputs, that is why it is called 16 to 4 encoder. Now we talk about the binary representation of the hexadecimal. So it is called 4-bit encoder because 4 bits maximum required to represent a hexadecimal number into the binary. Alright, it's a very simple thing and easy to understand. Suppose I write here number 1, then every time I move towards the left hand side I write 2, 4, 8. That means twice of the previous number. 1 into 2, that is 2, 2 into 2 is 4, 4 into 2 is 8. When I add all these numbers, what do I get? I get 15. 15 is the last number of the hexadecimal number system, or we call it F. That's why I've written both the things here. Right. So all these numbers are going to have the value 1, 1, 1, 1. And this 8421 can also be written as 2 to the power 3, 2 to the power 2, 2 to the power 1 and 2 to the power 0. Similarly, I want to represent 7. So in 7, we start from the leftmost side, and that is 8. So 8 is not required because we have to represent 7. So it will be having 0. Then 4, 2, 1, all are true, 1, 1, 1. Alright, so that is the binary representation of hexadecimal number 7 or base 16. Alright, I hope you have the clear idea why it is called 4-bit encoder and why it is called 16 to 4 encoder. Alright, now we are going to discuss the basic structure of the hexadecimal to binary encoder. Alright, now here you can see that numbers are written this side: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the hexadecimal numbers. A, B, C, D, E, F. These are representing what? Input. And these are the lines drawn for all these hexadecimal numbers, and these are the switches here you can see. Now these are the 4 gates or 4 OR gates which are representing the outputs. So you will write F0, F1, F2 and F3. You can also write 2, 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3 for your understanding. Otherwise, in the examination, this is not required. Just write F0, F1, F2 and F3. Now, how to make the connection? I told you just now that F or the 15 will be having all ones, right? Means it has to be connected with all the gates. So input will be sent to all gates here from this line. So this input from F, this is the input from the F, and this is the input for the F. And then you get the output 1, 1, 1, 1. For what? For the hexadecimal F. Okay. Similarly, if I want to represent, say, 8. So we have 8 here. This is the line of 8. Now this 8 line will be connected with this only, because this 2 to the power 3, that is going to be 8. Similarly for 9, I need 8 and 1. So you can see a connection from this 9 line to this what 1. Is that clear to everyone? Now on the basis of this small example, I will go for the actual circuit where all the connections are there. You can see, and you just check. These are the OR gates, these are the switches, these are the numbers written here, hexadecimal numbers, and these are the lines for these numbers, and now these are the inputs or connection. This is the input for this these OR gates. Pick up any example, say this time D, right? So here it is representing what? 11. So 2 to the power 3 will be connected, then F, that is 2 to the power 2 will be connected, and then 2 to the power 1, that is F0 will be connected. Alright, so I hope everybody has the clear idea of how to draw the circuit of the hexadecimal to binary encoder, right? And how to draw the circuit, how to understand the concept. Thanks everyone. You can just check all the connections here, right? Whether it is for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. That means for 10 onward, that is A, B, C, D, E, F. And remember, for 0 we don't establish any connection, no input is sent. Alright, thanks everyone.